to Doctors Christian Brenes and Wally Renne.
Well, thank you everybody for joining. We're going to be sharing some information about this topic that nobody's talking about right now, right? COVID-19 is our new hot topic. I thought digital dentistry was the hot topic, but this one is really hot topic just because it's impacting everyone worldwide. And I think it's really important that right now that everybody's doing webinars, we have a webinar that we can share with people that can spread some knowledge as far as what we can do as dental professionals to help not only ourselves with digital technologies, but also help others in this really sad situation we're going through. Everybody knows, I guess, Wally Renne. He actually, I'm part of the team right now. And I have been working for a couple of months at MUSC, the Medical University of South Carolina. He is the Dean of Digital Dentistry, something unheard, quite honestly. I mean, they have been doing really great things at the university. And that is basically the reason why I joined the team. I think they're doing great things for the profession. Innovation there is outstanding. It's a state-of-the-art facility. And Wally is actually one of the leaders. So I'm very glad that he is here joining us as well, because as a team, we have done a couple of things now to help with this pandemic, including masks. We're going to be talking about a couple of these. This one is one of the first prototypes. I'll try to get closer to the camera here. One of the first prototypes using this filter, which is the P100 from 3M, and there's another one from Honeywell, different brands. And we have another one here, which is a prototype that we did at MUSC that includes a little box in which you can use HEPA filters, but don't worry, we're going to be covering all these topics, and Wally's going to be explaining some of the differences in between the masks. On my end, I need to start. Well, Wally, do you want to add something before I get started?
No, you're good, man. I'm just happy to be here.
Awesome. So just a quick disclaimer, we are not virologists, we're not pulmonologists, and all the data that we have is basically gathered from some more professionals that have been willing to share that information with us, and from articles. Most of these articles actually talk about not even the COVID-19, because that's pretty new and we don't have a lot of data about it. But it talks about previous research done with SARS virus. SARS is basically an acronym for severe acute respiratory syndrome. And then MERS, which is causes the Middle East respiratory syndrome. So it's important to know how this actually got started before we start talking about different topics here. So it just happened that the World Health Organization got reports from an epidemic that it was unexplained. It was a respiratory disease. And this was in Wuhan, China. When the World Health Organization got this report, the etiology was attributed to some sort of coronavirus that it started there. We know it's part of the coronavirus family, and they named this virus COVID-19 as an acronym for coronavirus disease 19. So at this point, we don't have a lot of information. This is pretty new, and we're trying to fight this virus as a pandemic right now. I'm going to share my screen real quick here. So let me know if you guys can see my presentation.
Yeah, looks great.
Yep, looks good,
looks
Christian.
Good. Yep. Okay. Is that full screen, or you guys
no,
can see my?
It's like the presenter view.
Okay. Good deal. Can you guys still see me, or
yeah, this
just
is
the
great.
screen?
This is great.
Okay. So basically, in the as I was explaining, let me get rid of this poll. Anyway, I was explaining about this virus. In just a matter of weeks, maybe even days, we got many different recommendations, and the recommendations have changed quite a bit when it comes to safety and different things we can do to fight the virus. The reality is that we have noticed trends from different countries. And one of the major trends that we have seen, especially in countries that have been using masks, is that there is a trend to reduce how people or how many people are getting infected just by letting the overall population use masks. This is one of the main things that can be used right now to fight the virus. There is obviously a shortage in alcohol and different things that we know we can use to fight the virus. But there isn't a specific trend with this kind of devices, in particular masks, to help us reduce how quickly and how effective the epidemic, in this case a pandemic, can be reduced in a certain population. Now, at the beginning, this is what was happening actually. You know, at the beginning it was motivated that, or it was actually chaired by different organizations, that people in general should not be using masks, mostly because there was a fear of saving masks for healthcare professionals. And if everybody was going to start buying masks, then all of a sudden, all the people in the hospitals, healthcare professionals, would have a shortage. But it doesn't really matter what happened. We still have a shortage of masks. And these recommendations have changed quite a bit as well. So we noticed this, you know, being in an academic institution, we really become aware of national and state issues before, I will say, the general population. The most, I will say, possibly the most dangerous thing about this virus is not only the possibility that it can infect people really quickly, and people that are in risk can die, as we have seen in Italy, Spain, and many other countries. But one of the major problems is actually the fact that there is an exponential infection rate. In no country as of right now is actually prepared nowadays for such a demand of medical supplies. So what is going to happen? Okay, the virus can spread really fast, and then after it spreads, everybody's going to go to the hospital, and we don't have enough equipment, enough resources to try to treat all these patients that can potentially be coming to healthcare facilities. So we were aware of the situation, and we started developing what we will call a Plan B weeks ago at MUSC. Try to come up with different ideas of, okay, what is the worst case scenario? And if we are going to be prepared for that worst case scenario, what things can we do as, in this case, dentists, to help fight this crisis? So obviously, having on hand different 3D printers and different digital technology tools that we have, we actually, in this case, Wally came up with a team of professionals, and we try to design a couple of things. And I will say probably some of those things were mask prototypes. Wally, can you explain their roles at the university?
Yeah, so we constructed a team of pulmonologists. We have some epidemiologists, we have microbiologists, we have engineers, we have just phenomenal people in general that all kind of collaborate on this and try to make something that was going to be easily printable and would have the ability to be assembled and used all around. And so that's kind of where we're heading with this.
Okay. Yeah, I mean, as a matter of fact, all these mask prototypes that Wally's going to be showing, we personally test those at the hospital, looking for leakage and looking for possible filtration. So these have been approved at least by our healthcare facility in case there is a shortage, that we can start producing these kind of masks as well. So this is, in the people that can see the presentation there, this is basically the new rationale behind what we're going to be talking about. The new rationale is not only the fact that the government is promoting this, even though things have changed in the last couple of days, but implementing this in a way that everybody is aware is really important. Everybody should be aware of this. What you see here are basically the projections based on the number, in this case, million of cases, and the bell curves that are associated with basically doing nothing, which is that red line that you see right there. If people in general don't do nothing, these are the projections that people will actually see, which is going to be over, at least this is in the United States, is going to be over 50 million people, 57 million cases to be precise, is what we will expect if we don't do nothing. I think personally, you know, I will have to be honest. At the beginning, I never thought it was going to be that bad. I thought it was going to be more like a flu or something. But then I started noticing the trend, and it became a little scary. So that's the red line right there. So it's basically a trend if we don't do nothing. And then that green line that you see right there is the representation of projections based on the fact that we can use a combination of social distancing and masks. If you say there is a reduction based on these projections, there is a reduction of around 50%, 50% of the risk, which is it's quite good if we talk about a virus that is exponentially growing. The other thing is, if you see the difference, is not only estimating how many cases we can basically reduce as far as the risk factor, but the other thing is in what period of time those cases are gonna get infected, how many patients are gonna be infected in a period of time. And as I was saying, if we can reduce that in 50%, but also we can provide a larger period of time, there is a less risk for healthcare facilities to actually collapse. So we're basically spreading the amount of cases that are infecting over a longer period of time. And that way we can go with the supply and demand rationale to be able to see most of these patients. So it's really important to recognize that we have to have hygiene. We have to follow hygiene instructions. We need to use social distancing, and masks are basically one of the things that we should apply, not only as healthcare professionals, but the population in general. Okay, so let me talk about this, because this is also really important. This image is actually very popular now in social media groups. It's a new image that I've seen in a lot of different Facebook groups and social media groups. And it basically represents how the airborne diseases can potentially spread over distance. They can spread as cough or sneezing ballistics. So an infected person, just by breathing, can spread all these particles in a radius of 1.5 meters, which is around 5 feet-ish, 5 feet-ish, just by breathing. That is unbelievable. So that's why social distancing is really important. Now, if they cough or if they sneeze and they don't have anything to cover, they can spread that pretty far away. I mean, we're talking 1.5 meters or more than 2 meters, which is around more than 7 to actually 20 feet distance. That radius is pretty scary. So, you know, if you're in a room and somebody's sneezing, that's why at this point everybody's freaking out. Somebody's coughing, somebody's sneezing, and then you have 7 or even more than 20 feet of distance that the virus can travel and can infect more and more people. Not only that, but the virus can stay in different surfaces. So somebody will cough, and if the person is infected, the droplets can stay in different surfaces for a long period of time, and somebody can come later, they can touch the surface, get infected, and then get the virus into their system. So it's really important to recognize that also the COVID-19 is pretty small. We're talking microns here. And this representation that you see on the screen are for droplets that are below 10 microns. The reality is the virus itself is, if I'm not mistaken, is around 120 microns. But now, obviously, those viruses are not alone. They're usually covered by droplets, some sort of saliva or liquid. So when we talk about how we can potentially reduce the risk, we need to talk about particles that are less than 300 microns. So this is basically the standard of care. As of right now, in healthcare facilities, is using N95 masks. These N95 masks, the special thing about it is that when you're dealing with such small particles that are highly contagious, you need to use something like this in order to protect yourself. They offer much or better protection in particles that are less than 10 microns. Now, this is the thing. The Center for Disease Control and Prevention, at the beginning, when we're talking about this disease, the official recommendation by the CDC and FDA was that non-healthcare professionals shouldn't be using these masks, or I'm sorry, shouldn't be using masks that are not N95 just because they were not effective. And the reality is that is true in certain way. We will review the different kind of filters, and we will review the different kind of masks that we have. But the reality is, if you're using regular masks that are not N95, basically, those masks are usually used to filter particles that are larger than 10 microns. In this case, when we talk about coronavirus, COVID-19, SARS, these kind of particles that are less than 10 microns, the efficiency of blocking those particles can only be achieved with a mask like this or higher filtering. So the National Institute for Occupational Safety and Health, which is usually called NIOSH, they have different classifications for masks. When it comes to masks, they have an N classification, which is, they have N, R, and P. N stands for non-oil resistant. For the most part, in healthcare facilities, we use N masks because we're not dealing with oil. But the most important thing is not the classification about if it is oil resistant or not. In our case, the most important thing is that we need to know the number, because when it comes to the number, for example, 95, it basically stands to masks that can filter 90% of particulate matter. Those are usually good for short-term use. but long-term use is not quite that good. N99 usually stands for filtering 99% of particulate matter, and is generally adequate for safety. But the reality, and it just depends on what is your job. I mean, what is your job as a healthcare professional? If you use that mask for a long period of time, that 1% that slips through can still dangerous over a really long period of time. So we still don't know how many uses you can get out of a single mask, but that's something that we have to be aware too. You can reuse it, but we don't know for how long, especially if you're sterilizing these masks. And we're going to be talking a little bit about that topic too. Then there is another classification, which is N100. N100 is basically the best filtering you can get. It usually filters around 99.9% of particulate matter. And still, those tiny trace amounts can slip through. I mean, there is no mask that is perfect, if you will. But even there is that little trace amount. That trace is not it's not enough to be harmful without a sustained exposure for a long period of time. So if you see the P100 filter is basically an N100 filtering, if you will. The only difference in between the N and the P is the fact that P is what means that it will be resistant to oil. So the P100 is a filter that most people in the painting industry will use sometimes, or even to treat surfaces with asbestos that can cause cancer. This is what these people will use, which is a pretty good high filtering, and it can be used for a long period of time. Obviously, we have to take care of the filter. Try not to touch it with your hands. Try not to, manipulate it in ways that you can possibly open the surface or can make those pores that the filter has way bigger than what they are. So people just have to be careful with that. But the fact is, a new filter is 99.9% filtering the particulate matter. Now, this is what we see in social media. Again, all these posts and all these people, they're trying to help, and we really appreciate the willingness of people trying to do something. But the fact is, all these masks that you see on the screen are not effective against the virus, okay? Now, according to the CDC, when they come up with these recommendations, even though the CDC says they don't offer much protection against something like COVID-19, so healthcare professionals, in my opinion, shouldn't be using this to treat patients. The fact of the matter is that partial filtering is still better than no filtering, still better than nothing. So why this is important? Because even though imperfect protection doesn't mean completely useless, in a way that, if you use this mask, you can still have a lot of risk. If you're treating patients that can be infected with the virus, you can become infected. In a way, yes, but the other thing is, why using a mask, even though it doesn't have a high filter, can be useful for the whole population? The reason is this. The reason behind that is this. I wish everybody will have a high filtering mask, but even if you don't have one, the fact that you can use a mask will possibly help quite a bit. This is because it can also lower the number of aerosol droplets from cough and sneezing expulsions. So it's not only the fact that you can protect yourself from inward protection, if you will, but the outward protection helps a lot. The outward protection basically raised the question. So if all the particles, um, if all we want is to mitigate the pandemic, how much does a four-fold reduction of particles will reduce the transmission from person to person? That's the whole question here. So the intuition will suggest that even an imperfect mask will possibly offer a similar protection to something like social distance, washing your hands, or not touching your face. And that's why it's really important. So if somebody believes that he can be infected with the virus, and he can be, he can have the virus for whatever reason, especially healthcare professionals. If you're treating patients, urgent care, and you're treating patients, and you might think, well, I don't feel bad, I don't have any symptoms, but I would just go shopping, and I would just I need to continue my life, even though you don't feel like you need to wear a mask. Is good for the whole population to be aware and help in a way that even if you don't use a high filtering mask, you can go ahead, get any regular mask, and have your social life out there, and try to reduce the risk for everybody getting infected. Okay, so now there were a lot of questions. We came up with these mask prototypes a couple of weeks ago. And I got a lot of questions, especially in social media, regarding, because we don't really know what a HEPA filter was. Quite honestly, I didn't know what a HEPA filter was a month ago. But we did the research, and there's different types of filters. We have EPA, HEPA filters. Then we have HEPA, HEPA filters, and we have OPA filters. By definition, EPA stands for efficiency particulate air. HEPA stands for high efficiency particulate air. And then the OPA is basically for ultra low filters. Now, when it comes to the numeric value of it, we have, for whatever reason, we have 10, 11, 12, and then we have HEPA 13 and 14, and then we have the OPA. When you see the retention percentage of those filters, the higher you go, the more filtering you get. So basically with HEPA 10, it will get around 85% filtering. 11, you will get 95, and then 12, you will get around 99.5%. The recommendation that we're following, based on healthcare professionals and based on things that the industry has developed for things like air purifiers and vacuum filters, and try to reduce the risk for potential infections, is to use HEPA filters. So with a HEPA filter, HEPA 13, you will get 99.95% filtering, and HEPA 14, you will get 99.99% filtering. So if we talk about viruses like, for example, SARS or coronavirus, COVID-19, knowing this virus is so tiny, and we need to use high filtering as healthcare professionals. Now, even though OPA filters are tentative, because, the temptation is to use whatever will protect us the most, it just becomes unneeded in a way that it can be overprotection. And the fact that you have so much filtering is very hard for people to use that kind of filtering and breathe normally. Sometimes even with valves, that's something that will happen. So at this point, even though it's a temptation to use something like OPA, the fact that you cannot breathe really well in the fact that you have to inhale and exhale, it can create some sort of pressure inside the mask. And not only the fact that the fact that you will exhale the air, it can cause leakage around the seal of the mask. The other concern is the possibility of accumulating a lot of carbon monoxide inside the mask, and you don't get enough oxygen. So that's the main concern. We have to, at this point, we have to stick to HEPA filters, and this is what we're gonna be talking about with the mask prototypes. And I will let Wally go from here.
Thanks, Christian. Hey everybody, Wally Renne here, chiming in now. We're going to switch gears and talk about some applications of printing in the COVID-19 crisis, specifically relating to PPE and test swabs and things like that. So the first thing that you have to understand, in the dental world, we're considered a very high occupational risk for contraction of COVID-19 due to dental aerosols that are generated when we work in patients' mouths. And there's just so much lack of data out there regarding what we need to do to protect ourselves, if it's even worth investing in say N95 masks versus standard surgical masks versus these 3D printed masks. I mean, the reality of it is if you look at the actual evidence in the literature, there's no difference in standard masks that we've been wearing for decades and N95 masks as it relates to contraction of these viruses. There's just not enough information out there to really go by, so people are paranoid and they're wanting to do crazy things like have us in hazmat suits like we're entering into a room of anthrax. My personal opinion is that this crisis is important and that we need to protect ourselves, but we don't need to overreact, and we don't need to create more problems for our profession than really exist. With that said, though, we are at a unique position in that we are probably the highest risk profession. Dentists, because of the aerosols that we generate, are most likely to contract this working on patients. With that said, if you look at South Korea, they did not stop dental treatment during the COVID-19 crisis, and actually there's only one reported case out of the whole entire country of a dentist contracting the virus through patient care. So it's kind of confusing with that said, even though we are high risk. So regardless, there's a shortage of masks right now. No matter what you try to get, it's almost impossible to get masks. In fact, people are using expired masks from like long time ago and all sorts of things, and they're using masks all day long. They're using masks multiple days, like an N95 mask they're putting in a brown paper bag and saving it for later. It's crazy out there. So MUSC decided to try to combat this problem through 3D printing, and there was a team that created this kind of mask. Christian Brenes and myself and Dr. Yost and others created this kind of box, HEPA filter box design. That was mostly the brainchild of basically John Yost and Joshua Kim. So this is a box that's meant to be 3D printed and put together and a homemade HEPA filter cut and glued in place. It's really simple to manufacture. We did test these for seal and against bitter aerosols to make sure that it was filtering properly. But basically you 3D print these using the best printers to use are cheap printers for this, like a $250 fused deposition modeling printer, like a Creality CR10 or CR10 Mini or Ender Pro or something like that. But basically you print these components and then you glue together. You cut out a true HEPA filter in a square and you hot glue it in there, and you glue all the components together, making sure to put the rubber valve in the proper location and everything like that. These files are freely available with detailed instructions on how to compose these as well. Now, if you're printing out of various different materials, we'll go into in a minute, there's some really cool things that you could do with the printed materials, including like heat forming it to your face and things like that. Now, what is the safety of a HEPA filter? Well, There's some rumors going around that HEPA filters contain like nanoparticles of glass that when you cut it, you'll breathe it in and die, a near instantaneous death, if not a slow, painful death from cancer. That's not true. If you look at the MSDS of most HEPA filters, there's some MERV 16s that might have glass particles, especially big in the 80s and stuff like that, but now they don't. They use like a polyester fiber or a polyvinyl chloride fiber or some other type of plastic, woven plastic particles to filter out the viruses and bacteria. They don't use glass anymore. But anyway, if you look at the efficiency of HEPA, HEPA is actually roughly equal to a P100, so or like an N100. So a N95 mask, that's all the rave these days, filters out 95% of particles, 0.3 microns and larger. The HEPA is rated to 99.8% of particles, 0.3 microns and larger. So it's better than an N95. But there's some things that you have to be mindful of when you assemble this and everything like that. If you're not assembling it in an airtight seal, you're going to have issues. So there's various different things you could print these out of. And every material has its own kind of eccentricities that you have to be aware of. For example, PLA, which is a plant-derived polylactic acid, is a very biocompatible material, very cheap, and prints remarkably well. It is a relatively low temperature thermoplastic, so right around 200 degrees, it starts to melt in a liquid form. But if you put it at 100 degrees, it'll actually be thermoplastic to where you can conform it to your face. And so basically what you do is you print this thing, and to get the final fit to your face, you heat with the blow dryer the edge of the mask and form it to your face. Just be careful you don't burn yourself. PETG, polyethylene terephthalate, is a much more stable material. It melts at a higher temperature, more like 250, 260 degrees Celsius, and it is more resistant to chemical sterilization agents such as ethanol, isopropanol, and things like that. So it's a little bit more chemical resistant, but it doesn't heat form to your face because the temperature needed to heat it would be too high. You'd burn your face off. ABS is not a good material to use because it has some chemical off-gassing that you don't want to breathe that in. TPU, which is thermoplastic polyurethane, is a fantastic material. It's like a rubber material. It prints flexible in and of itself. It's awesome, but it is also super expensive and slow to print and hard to get to print on many fused deposition systems. So for that reason, we created like a split design where you could print one part out of TPU and the rest out of plastic, and all that kind of jazz, and combine them together. But once you combine two things together, there's even a little bit greater of a risk. But here's showing a mask that we printed out of TPU, and look at how cool it is. It's completely flexible, so it's more comfortable on your face, more likely to get a seal. Very cool. But if you are printing, let's say you're printing out of PETG and you can't heat conform it to your face, or even if you do heat conform PLA to your face, you still want to create some kind of seal. So there's medical grade silicones that you could use. If you're a little bit more risky, you could use window seal tape and things like that to get a neoprene tape to get a seal against your face and to make it more comfortable. So once again, there are detailed instructions on how to assemble this box system. It's kind of relatively easy. Mark a line 1 inch away from the bead line. You're gonna basically do some fantastic stuff with it's pretty easy to manufacture these things. It's pretty easy. You're gonna essentially use a HEPA filter like a MERV 13 or something like that. These are the pleated filters. Make sure it's HEPA certified, and then you're going to just cut out a square. There's some templates given, and you're basically going to then get about 10 pleats, and you're going to glue that into the box construction design. It does take a little bit of time to get this right. There's some skill that goes into assembling this thing because, like I said, you have to assemble it appropriately, or else you're going to have leakage of air, which defeats the whole purpose of having a mask. And it's something that you just want to be mindful of. But here we go. We have the MUSC safe box printed out of PLA here, and we are snipping this filter design, this HEPA filter, right into place. So here we are snipping it. Perfect. And now we are going to use copious amounts of hot glue. Remember, PLA has a low melting temperature, so be careful not to melt the actual plastic itself. So you want to be kind of fast with the glue, or use a low temperature glue. They have low temperature glue guns available now that are really quite good. Take your time here and make sure you're getting a true seal. So overdo the glue. It's okay to be a little bit messy here. And you know, this process here has been criticized a little bit, because what if you screw up here and you have a void in your glue and you're not truly sealed around your filter? All valid points, guys. This is not to replace a FDA approved N95 mask. This is for people who have nothing, and literally millions of Americans have nothing right now, but they do have a little 3D printer. In fact, most high schools, colleges all have these 3D printers, and you could print this thing for about $1. So it's not super expensive either. Really quite easy to manufacture if you spend a little bit of time getting this right. And so the last thing is you put the shield on top, which kind of seals everything down and into place. And we did test this for seal. So we tested multiple ones, and it's if you assemble it correctly, you have no problems at all having a seal through there. Not allowing virus particles to go through. The last step is to make a valve, a one-way valve on the device. One-way valves are kind of important-ish, not really with a pleated filter like this, but it would be more important if you had a single filter that wasn't pleated, because the surface area is so low it's hard to breathe through, and when you exhale, air wants to leak out the sides. But this is a valve nevertheless. You basically use the template and cut a little rubber flap and super glue it on top of that. So when you inhale, it sucks down and seals. When you exhale, it blows out. Now, if you're worried about, well, what if I'm sick and I'm blowing out my air everywhere? Well, you could just completely seal that down and all four sides and not have to worry about it at all. It's fine. And so then people were like, that's cool, but I don't want to mess with, tinkering around with cutting and arts and crafts and stuff like that. So I fabricated this box design. This was an earlier prototype. So you could snap in Roomba filters, vacuum filters, HEPA filters. This is the Roomba 700 filter that would snap into place. These are super cheap. Here's some examples of the mask design that I did. And then we noticed that they could be slimmed down further, which helps when you're seeing patients in dentistry. So I could get rid of all that dead space. And we did. So we shrunk that down and we made super compact versions. And then people were like, well, why do I have to print them separate? It's cool, but then I got to, combine everything. Why don't I just print them combined? So I made an integrated mask design, which is really cool. Rob Harding helped me out on this. And then people complain, well, these are super cool, but they're hard to print. You have to have a ton of supports, a jillion supports, and they take a lot of resin and a lot of hours. So that's a valid point. And this is just showing the HEPA Roomba filter snapping in place there. Perfect fit. If you were worried about the seal there, you could put some hot glue around that as well, or some polymer-based silicone. That's printed out of a durable resin that's slightly flexible. I've been using the SprintRay Pro printer to prototype a lot of these. This is probably one of the best dental printers on the planet right now. It's got a huge build platform. It's fast. This mask printed in like 3.5-4 hours, which it's a really nice printer. But look at all these supports that you have to have. Those supports are necessary in order to get it to stick to the build platform. So I worked with Tobias on creating an easy print mask. Basically, these masks print flat with no supports, which cuts down the time by a few hours. And also, especially if you're using FDM, it cuts down the time by about 10 hours. And it also decreases resin consumption. So this will print in 3 hours here. Beautiful mask. It takes the MUSC safe cartridge design, and it takes the other Roomba designs as well. So really cool. Now, we felt like we could improve even more. So we created another version of the Easy Print mask for the i7 filter, which is a much bigger, actually better filter. it's a better rating and it's more protective. We also created this mask, Christian and I, that actually snaps in a 3M filter. All these files are available on Thingiverse right now, on my Thingiverse, for free for download if you want to tinker. The 3M filter P100 snaps right in. P100 is better than a N95 mask. It filters out really, really good. This would probably be the best mask design. However, it's impossible to get P100 filters anymore. So then we tried to improvise and say, okay, what can we do if you can't get P100 filters anymore? So we created our own kind of filter design where you could cut a circle HEPA filter and bond that in place. And this mask is also on Thingiverse. Another cool design, actually one of my favorites, is by Brenes and Dr. You could go to his website, Disruptive Dental Specialist, brenesanddr.com or something like that, and download it for free. Really cool design. This is showing fused deposition modeling printing of these masks. I still think FDM is probably the best way to go with these masks because you could print out a PLA and then thermoform it to your face to get the final seal. Fused deposition modeling printers are wicked cheap, literally like $200. So then people said, well, if you're printing these using fused deposition modeling, how can they be airtight? Because people are all paranoid. Well, the reality of it is there's some really good studies that show it's actually kind of easy to create airtight prints. People were concerned that the little layer lines would have micro leakage of air and therefore viruses could get in. Well, that's true if you're not following the protocols. And basically the study showed that you need a flow rate of 98 with 100% infill. And that's easy to do on any slicer software. It's kind of pretty routine. It's like 2 clicks and you could have a flow rate of 98 and a infill rate of 100%. And if you do that, looking at these different materials, you could show airtight prints here, guys, which means nothing's getting in or out that you don't want. It's all going through the filter. So infill of 100% is critical. Another thing that's like in wicked low supply are face shields. We've been printing face shields. Now, we didn't design our own face shields because there's some really good ones available. My favorite probably is the one by Prusa. All these are free. And so this one's really cool because it has a 3-hole punch design where you could take this is from Amazon, these poly vinyl chloride sheets. And you could just do a 3-hole punch and it snaps right onto the face shield. So it's really cool to be able to play with these things. Here's another design that's really good. And those little neck straps there are to relieve strain on your head. They go on the back. So what about ventilators? Ventilators are a little bit more touchy of a subject. This is probably the best design. It's an Italian group. If you want to know more information about it, they've developed a Charlotte valve that hooks up to this scuba mask that could then go into a ventilator. It's a really cool design. You could get that mask for like $100. It cost about less than $1 to print that valve. But the issue is that requires a really cool ventilation machine and things like that. So this is something that we helped develop. This is go to worldwideventilator.com and look at the progress of this. We're printing and testing this right now as we speak. It's a really cool solid state ventilator design. It's a bifluidic stable amplifier that basically uses the patient's it uses compressed air to go into one valve, and it uses the patient's own kind of inhalation and exhalation to help assist with breathing. If you breathe more and you're doing okay, it works less. If you're not breathing well, it works more. And this is some that we printed on the Sprint Ray Pro as a solid state print. So it's hollow in there with those, that's like, once again, it's a bifluidic stable amplifier, which was developed by the military and Harry Diamond in the 60s, and we modified it to make it better and more applicable. Basically, all you need is a BiPAP or CPAP or a compressed air oxygen source to go in. So you don't need a fancy ventilator system. So this would be really good for like third world countries who have nothing, and they could get compressed air sources, and this could be printed for like $1. And this is just showing fluid movement. I'm going to inject. This is one of our earlier prototypes. We've done a lot to make it better, especially as it relates to printing. There's certain things that we've done to improve, but you could see it's hollow inside, and those channels basically are exhalation and inhalation ports, and it's designed to assist the patient in breathing. If you want more, go to worldwideventilator.com to learn more about that. Also, there's a worldwide shortage of COVID-19 swabs, test swabs. I mean, we can't even test at MUSC because we're out of swabs, and the 20,000 that we ordered from China were all contaminated. So we are frantically printing these and testing these using mechanical property testings. The bottom one is one of the ones that I designed. Here they are printed and printed out of surgical grade resins that could be autoclaved, and they're just really cool. We're in the process of getting these approved right now. One of the best materials we found was key splint soft to print these things out of. People are also printing ventilator splitters so that one ventilator could work off of 2 people. It's kind of frowned upon in the pulmonology world because it messes with being able to track that patient and things like that, but it's better than nothing. All right, so all these printed things are really cool, but what about disinfection? That's kind of come up a lot. Well, there's some studies show that 405 nanometer wavelengths of light do a really good job at inhibiting this virus and actually other bacteria and microbes as well. And if you look, the time of exposure anywhere from 5 to 20 minutes, depending on the distance of the light source. So obviously, the closer your mask or your visor or your ventilator is to the UVC source, the less time of exposure that you need to do. And these studies did 4 and 6 feet, but there's boxes that you could create that have the appropriate milliwatt output of 405 nanometer light that could put you within inches to the source, dramatically decreasing the amount of time that you need to expose to UV. Now, if you don't have access to UVC, and a good old school ethanol bath is actually works fantastic. This is a study that shows that 30 seconds even 70% greater ethanol or isopropanol works fantastic. So we actually do a 5-minute bath. So if you dip it for 5 minutes, you're going to be good to go. Here shows a printed PLA mask where we tested it after 70% ethanol, and it worked really good on both PLA and PET-G. Another thing that you could do is hydrogen peroxide vapor sterilization. So many hospitals have this. It's cold hydrogen peroxide gas vapor, which could actually sterilize filters as well. So if you want to reuse your filter, you could probably do that. So anyway, I do want you guys to know that we're really doing some fun stuff with the dental equipment that we have, and we're trying to innovate. We're trying to push the limits of what's possible with 3D printing and trying to help in general. And all these files are freely available if you want to tinker at home and play around. If you're looking for a super cheap printer to get, the Ender 3 Pro is probably like a $230 printer that's really good. If you want to go up from there, the Prusa Mark 3S is about $1,000. That's fantastic. And then if you want to spend like 10 grand, 8 grand, let's see, the 8 grand mark, the Sprint Ray Pro would be beautiful, 7 or 8 grand with everything. And then if you want to go more money than that, you're gonna be looking at professional grade printers. So I don't even think it's necessary to do anything beyond a Sprint Ray Pro. But yeah, guys, let me know if there's anything I could do to help out as well. Leave some comments. Thanks.